Good evening, everyone. On behalf of agricultureinformation.com, I welcome Mr. Chethan Poojary, and he will speak on the topic soilless substrate and their importance designation. I now request the speaker to begin. Thank you.
Good evening, everyone. It's my pleasure to welcome you all in my today's presentation on soilless substrates and their importance. Agriculture is undergoing a major transformation for thousands of years. Crop production has relied almost entirely on natural soil. Increasing population, shrinkaging agriculture land, climate change, declining soil fertility, water scarcity, and soil-borne diseases are making conventional cultivation more challenging than ever before. Today, we have technologies that allow us to grow crop without depending entirely on natural soil. Only one of the most significant development is in the field of soilless substrate, which provides plants with an optimized root environment where water, oxygen, nutrient, and physical supports are carefully balanced. During this presentation, we will explore the science behind substrate technology, understand the physical, chemical, and biological properties of the growing media, discussion on crop-specific substrates. Agriculture today faces unprecedented challenges. The global population continue to grow, increasing the demand for food, fruits, vegetables, and ornamentals. At the same time, the amount of cultivable land available per person is steadily decreasing due to urbanization, industrial development, and infrastructure expansions. Climate change is adding another layer for complexity. Farmers are experiencing irregular rainfall, prolonged drought, and unexpected floods, rising temperature, and more frequently extreme weather events. These factors directly affects the crop productivity and profitability. Water scarcity is also becoming one of the biggest constraints in agriculture. These challenges require innovative solutions. Instead of relying solely on soil, we must develop a system that provide crops with an ideal growing environment while conserving water, nutrient, and all other natural resources. Another serious concern is the gradual degradation of our soil. Continuous cultivation, excessive fertilizer use, erosions, salinity, and loss of organic matters, which have reduced the fertility of many agricultural lands. Soil-borne diseases and nematodes further reduces the crop performances, which increases in production cost. Soilless substrate technology is one such solution and is rapidly becoming an integral part of our modern horticulture. And soil. Although soil has supported agriculture for thousands of years, it is not always an ideal growing medium. In many regions, soil suffers from compactions, which restrict root growth and limited oxygen availability. Compacted soils also reduces water infiltration and leading to poor drainages for waterlogging. Excess moisture creates a favorable condition for fungal disease such as Pythium, Phytophthora, and Rhizoctonia, Fusarium, etc. These pathogens attacks the plant's roots, reducing nutrient uptake and ultimately decreasing the crop yield. Another major issue is soil salinity. In many irrigated areas, salts accumulating over time, making it difficult for root to absorb water and nutrients. Similarly, weed seeds present in the soil compact with the crop for water, nutrient, and sunlight, and increasing the labor cost and and herbicide cost, etc. Nematodes are microscopic worms that damages the plant roots significantly, reducing productivity in crops such as vegetable, fruits, and ornamental crops. Traditional soils also show a considerable variability. Even within a single field, differences in texture, fertility, and drainages can lead to uneven crop growth. This limitation highlights the need of alternative growing system that provides uniform, predictable, and controllable condition for root development. Mm, Soilless substrate. It is one of the most common misconception in agriculture. Is that plant need soil to grow. Uh, in reality, plant do not require soil itself. What they actually require is suitable for environment that supplies four essential elements: water, oxygen, nutrient, and physical support for a root system. Um, For example, there are many substrate which we can use for as a we can use as a soilless substrate: cocoa peat, cocoa chip, perlite, vermiculate, and peat moss. Soilless substrate is much more than just a mixture of different materials. It is carefully engineered root zone environment designed to optimize the plant growth. Unlike natural soil, where physical and chemical properties are often unpredictable, soilless substrates are formulated to provide consistent performances. They are designed to hold sufficient water for plant uptake while maintaining adequate air spaces for root respiration. They also provide physical support, allowing the root to anchor the plant securely. Common substrates material include premium washed cocoa peat, horticulture perlite, vermiculate, cocoa chips, peat moss, mm, and many others are there. For example, cocoa peat stores water, perlite improves aerations, cocoa chips enhances drainage, and compost contributes the nutrient and beneficial microorganisms. By combining this material in an appropriate proportionate, we can develop a crop-specific growing media that maximizes the productivity under greenhouses, nursery, hydroponics, landscape, and urban farming conditions. Evolutions. The concept of growing plants without conventional soil is not entirely new. Historical records describe the hanging garden of Babylonian and floating gardens by ancient civilization, where plants were grown in alternative media. Over time, scientific advances led to hydroponics and controlled environment agriculture. Today, advances in materials such as cocoa peat and perlite have made soilless cultivation more accessible. The rise of protected cultivation, urban farming, rooftop gardens, vertical farming has further increased the demand for high quality substrates. Modern soilless cultivation is no longer limited to research laboratories. Uh, it is now widely adopted for commercial vegetable production, ornamental nurseries, tissue culture, hardening, landscaping, and home gardening. As the technology continue to evolve, precision irrigation, automation, sensor-based monitoring, and making soilless substrate-based cultivation even more efficient and sustainable. A root zone environment. The root zone is the most important part of plant environment. Everything that happens above the ground depend on the health and function of the root below the ground. Root zone environment involves designing a growing medium that provides the ideal balance of water, oxygen, nutrient, and structural supports. Healthy roots require enough moisture to absorb the nutrient, but also sufficient air-filled pore spaces to allow the respiration. If a substrate hold too much water, root may suffer from oxygen deficiency and diseases. If it drains quickly, plant may experience drought stress. By carefully selecting particle sizes and combining the materials such as cocoa peat, perlite, cocoa chip, we can create a root environment that supports vigorous growth. Vigorous growth. Importance of healthy soil. Healthy roots are foundation of every successful crop. They absorb water and minerals, nutrient, and anchor the plant. Synthesize the hormones and interact the beneficial microorganisms. When root develop freely in well-aerated substrate, plant establishes more quickly, grow vigorously, and produces better quality flowers and fruits. Healthy root also improves the plant's ability to tolerate the environmental stress such as heat and temporary water shortages. Poor root health often goes to unnoticed until visible symptoms appear on the leaves. By the time wilting, yellowing, or stunted growth becomes apparent, root damages may already be severe at that time. For the reason, successful growers focusing on preventing root problems rather than treating it them at later stage. Investing a higher quality of substrate is one of the most effective way to promote long-term root health and maximum crop productivity. Modern substrate combines several carefully selected material, each contributes specific functions. Uh, cocoa pit. Cocoa pit provides um, excellent water storage capacity while maintaining adequate porosity. Perlite increases the air-filled pore spaces and improving the drainages. Cocoa chips create large air spaces and improve the structural stability. That making them particularly useful for long-term crops. Vermiculate contributes additional water and nutrient retention, especially during the seed germination. Peat mosses enhances the moisture retention and commonly used in propagation media. No single material can satisfy the crop requirements. Soilless substrate often numerous advantages over conventional soil cultivation. They provide better aeration, consistent moisture distribution, improved drainages, and more efficiently nutrient use. Because soilless substrate are free from weeds and can be manufactured pathogen free, they reduces incidence of soil-borne diseases and lower the need of chemical treatment. Soilless substrate also support efficiency in irrigation system, reducing water consumption, fertilizer losses. Their lightweight nature makes them suitable for rooftop gardens, green houses, and grow bags, vertical farming, etc. Um, Perhaps the greatest advantage is consistency. Every container receives the same carefully developed growing medium, resulting in the more uniform crop growth, higher quality produces. Cocoa peat has become one of the most widely used growing media in modern horticulture because it offers an excellent balance of physical properties. Premium horticulture cocoa peat is washed and buffered before use. One of the cocoa peat's greatest strength is the ability to hold large quantity of water while still maintaining enough air-filled pores for root respiration. The combination allows plant to receive continuous supply of moisture without remaining waterlogged. Cocoa peat is lightweight, easy to handle, and environmental friendly. It performs exceptionally well in greenhouses, nurseries, hydroponics, grow bags, rooftop gardens, and landscaping. However, although cocoa peat provides a moisture retention, it is rarely used alone. For optimum crop performances, it is usually blended with the material such as perlite and or cocoa chips to improve the drainages and aeration according to the crop requirement. Perlite is naturally occurring volcanic rock that expands when it is heated to a very high temperature, producing lightweight white granules that with numerous internal air spaces. Although it appears simple, perlite plays a critical role in soilless substrate formulation. Unlike cocoa peat, which primarily stores water, perlite increases amount of air availability around the root system. Root require oxygen continuously for respiration. Without adequate oxygen, nutrient uptake and slows nutrient uptake slows, and with the uh, root diseases become more common. Adding perlite increases the air-filled porosity, improves the drainages, and prevent growing medium from becoming compacted over time. This particularly important for crops that are highly sensitive to waterlogging, such as tomato, capsicum, strawberries, succulents, and ornamental plants. Perlite is chemically inert, meaning it does not significantly affect the pH or electric conductivity. It also does not decomposes, allowing it to maintain its substrate structure throughout the crop cycle. It will not compact. The proportionate of perlite varies according to the crop requirement. Fast-growing vegetables may require moderate amount of perlite, while uh, succulents often much higher percentage of perlites to ensure the rapid drainage of root zone. And vermiculite. Vermiculite is another expanded minerals widely used in propagation media. Unlike perlite, whose primary function is aeration, vermiculite acts as a moisture and nutrient reservoir. Its layered structure enables it to absorb several times of its own weight in water. At the same time, vermiculite has a relatively high cation exchange capacity, allowing it to retain a positively charged nutrient such as potassium, calcium, or magnesium, etc., until plant root require them. Because young seedlings possess a delicate root system that cannot tolerate moisture stress, vermiculite is frequently incorporated into seedlings and nursery substrate. It helps maintain uniform moisture, reducing the risk of dehydration of seedlings and promoting rapid establishment. However, excess vermiculite may reduces the aeration because it is a high water retention material. Therefore, it is generally used in combination with the perlite or cocoa peat in the balanced manner. Cocoa chip. Cocoa chip are produced by cutting of coconut husk into coarser pieces rather than processing into in fine cocoa peat. They are large particle sizes creating macrospores within the substrate. It significantly improving the drainages and air movement. Long duration crop requires growing media that remain physically stable for many months. Fine material gradually settled and compacts, reducing oxygen availability to roots So cocoa chips resist decomposition and maintain the structural stability, helping preserve physical integrity of substrate throughout the extended life cycle of the crop, like uh, ginger, turmeric, or anthurium. Because of this characteristic, cocoa chips are commonly used for orchids, orchids, anthurium, and perennial crops. Excellent drainages for long-term root supports. When blended with the cocoa peat, cocoa chips create a substrate that combines high water holding capacity with the excellent aeration, allowing growers to customize root environment according to the crop requirement. Peat moss and several additional materials are incorporated into specialized structures and substrates to improve the biological activity and nutrient availability. Peat mosses possess exceptional moisture retention and uh, frequently used in seedling production, high value ornamental crops. Uh, Vermicompost supplies organic nutrients, humic substances, enzymes, and beneficial microorganisms that stimulates the root growth to improve the soil biology. And some biological additives are becoming increasingly important for sustainable horticulture. Trichoderma species colonizes the root zone, suppresses several soil-borne pathogens while enhancing the root development. Mycorrhizal fungi from the symbiotic association with the plant roots, increasing the phosphorus uptake and improving the drought tolerances. And neem cake contribute organic nutrient while suppressing certain soil pest and nematodes. Although these additives represent only a small proportionate of total substrate volume, they significantly influences uh, crop performances and contribute to sustainable root zone management. And water holding capacity. Water holding capacity refers to the amount of water retained by the substrate. A substrate with the low water holding capacity dries quickly, needs more frequently irrigation, and a risk of plant stress. Conversely, a substrate holding excessive water may reduces the oxygen availability and encourage the root diseases. The objective is not to maximize the water retention, but to maintain the correct balance between stored water and air-filled pore spaces. Premium cocoa peat typically provides excellent water holding capacity while maintaining adequate aerations, making it one of the most effective substrate material available. Water holding capacity also influences the irrigation scheduling. Understanding the property enables growers to determine the irrigation frequency and volume accurately. And yeah, air-filled porosity. Air-filled porosity represents the percentage of substrate volume occupied by the air after drainage. Although water is essential for plant growth, oxygen is equally important. Poor aerations favors pathogens like Pythium, Phytophthora, and Fusarium. Materials such as perlite and cocoa peat, cocoa chips significantly increases the air-filled porosity. Their larger particles create interconnected air channels that remains open even after irrigation. Modern substrate formulations aim to maintain an optimum balance between the water retention and aeration. Excessive water holding capacity without sufficient air spaces is just undesirable, as excessive drainages that leaves insufficient moisture available for roots. Air-filled porosity is therefore one of the most important property to understand the substrate science. Bulk density. Bulk density refers to a dry weight of the substrate per unit volume. It affects the transportation cost, container stability, water retention, and ease of handling. Lightweight substrate reduces the transportation expenses and make grow bag easier to move. However, extreme lightweight may become unstable under windy conditions or fail to provide adequate support for large fruiting crops. Commercial substrate manufacturers carefully control the bulk density and adjust the particle size distributions and proportionates of different ingredients. Maintaining a consistent bulk density ensures the uniform crop performances and simplifies irrigation managements. pH. The chemical properties of the substrate are just as important as physical properties. Two of the most critical parameters are pH and electrical conductivity. pH determines nutrient availability. Most horticulture crop performance is best when substrate pH maintained in between approximate 5.5 and 6.5. Outside this range, essential nutrient becomes less available even when present in sufficient quantity. Electrical conductivity measures the concentration of soluble salts. Excessively high EC can damages the root and reduces the water uptake, whereas very low EC indicates the inadequate nutrient availability. Routine monitoring of pH and EC enables the growers to adjust the fertigation programs before nutrient deficiency or toxicity become visible. So far, we have discussed physical properties and chemical characteristic of the substrate. Equally important are their biological property, uh, which have directly impact on our root health and crop productivity. Unlike field soil, a high quality substrate should be free from weed seeds and soil-borne pathogens, nematodes, and harmful contaminants also. These unwanted organisms compete with the crops for nutrients and or attack the root systems, reducing the plant vigor and increasing the product costs. Our major advantage of soilless substrate is that they can be produced under controlled condition. Premium substrates are screened, processed, washed, and often treated to retain contaminants. Um, Medicine contaminate conditions. This provides growers with a clean and predictable root environment. In addition to being free from harmful organism, substrate can also be enriched with beneficial microorganisms species such as Trichoderma mycorrhiza. The Trichoderma helps suppresses the fungal diseases while promoting vigorous root development. The future of substrate technology lies not only on providing physical support but also in creating biologically active root environment where beneficial microorganisms work together with the plant uh, plant roots and to improve the productivity naturally. Soil. Let us compare conventional soil cultivation with the soilless cultivation. Traditionally, soil has supported agriculture for centuries, but its quality varies generally. Its quality varies generally from one location to another location. Soil texture, fertility, drainage, soil texture and fertility, drainages, and biological activity differ even within the same field. This variation in the field often lead to uneven crop growth. Soilless substrate, in contrast, are manufactured under controlled condition, ensuring consistent physical and chemical properties. Even every grow bag or container receive same growing medium, resulting in uniform root development and crop growth. Soilless system are also free from weed seed, greatly reducing labor cost associated with the weeding. Since the soilless substrate is free from soil-borne pathogens and nematodes, disease presence in significantly reduced. Mm, yeah, And soilless system are also free. Yes, it's free from weed seeds. Drainages and aerations are carefully engineered, allowing root to receive adequate oxygen while maintaining optimum moisture. Although substrate cultivation requires initial investment and good irrigation management, the benefit in terms of the crop quality, productivity, water water conservation, and disease reduction often outweigh this cost. Yeah, water is becoming one of the agriculture's most valuable resources. Substrate like cocoa pit store water within their pore spaces, allowing a root to absorb moisture gradually between the irrigation cycle. This minimizes the water wastages while maintaining the favorable moisture condition. Studies have shown that protected cultivation using soilless substrate can reduce the water consumption substantially while maintaining or even increasing the crop yield. This is particularly important in the region experiencing water scarcity or irregular rainfall. Every liter of water conserved uh, contributes to more sustainable agriculture and helps ensure the food securely. And nutrient efficiency. Yes. Fertilizer represent one of the largest production cost in horticulture. Therefore, improving nutrient use efficiency directly improves the profitability. In conventional soil, nutrients are frequently lost through leaching, runoff, volatilization, or fixing within the soil. Plant often utilizes only a portion of the fertilizer applied. In soil substrate cultivation, nutrients are supplied directly to the root zone through fertilizer. Since irrigation and fertilization occur simultaneously, a nutrient remain available, uh, whereas the root can absorb them most efficiently. Modern substrate, this means a soilless substrate, also help retain water and dissolve nutrient while maintaining a sufficient aerations, creating ideal condition for nutrient uptake. This precision reduces the fertilizer wastage and minimizes the environmental pollution to improve the crop growth. Protected cultivation has transformed horticulture worldwide. Greenhouses and polyhouses protect crop from adverse weather while allowing growers to regulate the temperature, humidity, irrigation, and nutrient supply. These systems become even more effective when combined with the scientifically designed substrates because field soil often introduces disease and drainage problems. Container-based substrate are prepared inside the protected structure. Grow bags filled with the soilless media provide a clean, well-drained, and easily managed root environment. Protected cultivation also facilitates year-round production, improve crop quality, and it increases the productivity and reduces the pesticide use. As labor cost rises, the climate variability increases. Greenhouse production support by high quality substrate is becoming increasingly important. Hydroponic is one of the most advanced forms of soilless cultivation. Instead of relying on natural soil, plants receives nutrient through carefully prepared nutrient solution. Although some hydroponics systems suspended in roots directly in nutrient solution, many commercial operations use soilless substrates such as cocoa peat, perlite, or rock wool to support the root system. Grow bag or trough containers, uh, trough containing soilless substrate have become particularly popular for tomatoes, cucumber, capsicum, strawberries, blueberries, and many other greenhouse crops. Hydroponics provides excellent control over nutrient, oxygen, environmental conditions. enabling growers to achieve high productivity while using considerably less water than conventional agriculture. As urban farming expands, hydroponic is expected to play an increasingly important role in future food production. Vertical farming. Vertical farming represents one of the newest application of substrate technology. Instead of growing crops horizontally across the farmland, uh, plants are cultivated in stacked layer within a controlled indoor environment. Because natural soil is impractical in vertical farming system. Lightweight substrate becomes essential. This system combines soilless growing media with the LED lighting, automated irrigations, and climate control and computer monitoring. Vertical farming dramatically increases the production per unit area while reducing water consumption and eliminating dependency on weather condition. Although currently used mainly for leafy vegetables and microgreens, ongoing technological improvements may expand its commercial application to additional crops. Nursery production demands substrates that exceptional physical properties because young seedling possess a delicate root system. Propagation media must retain adequate moisture while providing excellent aeration to encourage the rapid root development. Cocoa peat blended with perlite and vermiculite has become one of the most successful nursery substrate worldwide. Tissue culture plants require even greater care during the acclimatization. These plants move from sterile laboratory condition into greenhouses environment, where root development is critical for survival. Sustainable substrate significantly improve the survival rates during the hardening while promoting vigorous growth before transplanting. Uniform substrate also produces uniform seedlings, simplifying crop management after planting. The commercial application of soilless substrates continue to expand rapidly. Today, soilless growing media are used in greenhouses, vegetables, ornamental nurseries, fruit crops, landscaping projects, tissue culture, rooftop gardens, indoor plants, urban farming, and hydroponic system. Grow bag or tough cultivation has become increasingly popular for tomatoes, cucumber, capsicum, and many fruit crops because it allows precision irrigation and nutrition management. Landscape industries also rely on heavily on these specialized potting mixes for palms, ornamental shrubs, flowerings, and indoor foliages plants, etc. Urban gardens increasingly prefer ready-to-use potting mixes because they are lightweight, clean, and free from weeds. Um, yeah. One of the greatest advantage of soilless substrate technologies is ability to customize the growing media for specific crops. In traditional farming, every crop grows in same soil, even though different crops have a very different root system. Modern substrate technology allows us to tailor the root environment according to each crop requirement. Tomatoes require excellent drainage because prolonged waterlogging reduces the oxygen availability and increases the root diseases. And cucumber have a high water demand and performs best in substrate with the greater water holding capacity. Like strawberry benefits from higher means lighter substrates that promotes rapid root growth while preventing excessive moisture around the crown. And turmeric and ginger requires balanced combination of moisture retention and aeration, structural stability because they remain in growing media for several months while providing rhizomes. Succulents and cacti requires exceptionally well drained media with a high air filled porosity, whereas Farms and landscape plants benefits from substrate that maintain structural stability for several years. The key message is that substrate formulation is not mixing materials randomly. It is about engineering a root environment that matches the biological needs of each crop. Now, um, our vision as the scientific innovation create value only when they are successfully transferred to end users. Our vision is to ensure the substrate technology are accessible not only to research institution but also to commercial farmers, nursery operators, greenhouse growers, landscapers, and urban gardens. Every grower should have access to soilless growing media that improve productivity while conserving the natural resources. Before concluding, let us summarize today's discussion. Healthy root system are foundation of successful crop production. Modern substrate provides carefully engineered environment where root receives the correct balance of water, oxygen, nutrient, and physical support. No single substrate is suitable for every crop. Instead, it should be customized according to the crop requirement. Efficient irrigation and fertigation conserves valuable resources while improving the product profitability. Most importantly, soilless substrate technology enables agriculture to become more sustainable without compromising productivity. Um, yeah, soilless future. The future farmers will not simply cultivating a soil. Future farmer will manage the root zone with the precision. By creating scientifically designed substrate, we provide plants with the optimal condition for growth while conserving water, reducing fertilizer losses, minimizing diseases, and improving productivity. As climate change intensifies, the agriculture land becomes increasingly limited. This technology will become essential rather than optional. Our responsibility to extend beyond growing crops. We must also conserve natural resources for future generation. Uh, Soilless substrate technology offers one of the most practical pathway towards achieving sustainable, profitable, and environmentally responsible agriculture. Uh, Thank you. I hope today's presentation has provided useful insight into the science um, of soilless substrate. Thank you for my listening my presentations.
Thank you very much, sir, for a wonderful presentation. I will take up the questions now. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video?
Yeah.
Okay, I'll move on to the questions, sir. The first question is, what are the common mistakes growers make while using soilless substrates?
Yeah. The common mistake means, ma'am, see, for example, they are using the only single type of substrate. There are many, means what I said, the substrate which suitable to water retention, and there are many substrate that has to be used for aerations. For a crop, first they have to understand the root and requirement of the plant roots, means requirement of plant root environment. See, cocoa peat generally it retains water. It has a very low percentage of aeration. These things. Generally, people use cocoa peat for every crop. Actually, it's not this one means advisable, because cocoa peat using cocoa peat without washing also. See, people should wash cocoa peat before use, because it is it contains high sodium, potassium, and alkaloid materials. Leads to a deficiency like calcium and magnesium, and even high EC cocoa peat is not recommendable for all crops. There's some tissue culture or seedlings they used to burn. Cocoa peat has to be washed before use, and even that has to be mixed with the perlite or some other light materials. That should be known by trial and error method, because in general different crop require different type of this growing media. Like for succulent, if you use cocoa peat, means it contains it requires a high aeration. Cocoa peat will not work there. So people should understand the root zone of the plant, how the plant requires, means water requirement of the plants. Um, Even perlite also. The perlite won't hold a high amount of water. That has to be mixed with the cocoa peat. The single type of substrate will not work there. That has to be mixed. And even pH, people should know the pH. Normally, crop require 5.5 to 6.5. That has to be balanced by using. There are many additives are available, or the that the substrate we can manage the pH. Uh, and pH and EC should be mainly important. Um, this higher pH and difference in pH leads to deficiency in nutrient. If you even though there is availability of nutrient in root zone, plant can't uptake the nutrient due to higher or lower pH. And yeah, that there should be specific. There should not be any specific subset for this crop. This should be a specific like that, and that we have to customize the substrate. And see, waterlogging means if a substrate having high water content, means it's lead to compaction over time, and it lead to drainage causes the poor aerations, and it leads to fungal disease, etc. That has to be cared. And even the monitoring of means the EC. They should. We have to monitor the EC, pH, and uh, drainages. Means the whatever the water we have added, that has to be drained well. Otherwise, the waterlogging may impact the substrate or plant performances. Likewise, there are many common mistakes. Um, Poor rain, poor irrigation, EC, pH, and even quality of water, poor quality of water, and improper cocoa peat buffering, mixing of incompatible fertilizers, poor aerations around the roots, and refuses to contaminating media, lack of routing monitoring, and that should be monitored well, and recordings data, and even the climates, like temperature, humidity, it also affects the plant performances here.
Okay. Sir, how cost effective is soilless cultivation for small and medium scale farmers?
Yeah, actually, soilless media, comparing to soil media, it is cost effective only because um, soilless media we can reuse this one. Soil, what happened in the for the over the period, it get compacts, and we have to mix with. We have to amend the soil. In the same way, substrate also. we can wash it again, and we can reuse it. And see, the density of the soil comes nearly 1,200 to 1,400 gram per cc. Same way, this one, soilless substrates, it comes with the density around 250, 300 kg per meter cube. Sorry, that's soil density comes 1,200 kg per meter cube, and soilless substrate nearly 300, 350 kg per meter cube, means nearly 4 times higher volume. It gives nearly 4 times higher volume. And it gives other benefits, like it retains water, it retains aerations, and it is disease free. And it gives higher yield in smaller area. Farmers soilless system allow closer plant spacing and more efficient root management, and significant water saving. Soilless cultivation typically uses 30 to 70% less water than conventional field irrigation, because water is delivered directly to the root zone, and the losses from the runoff and deep percolations are minimized. And even in compared to lower fertilizer also, lower fertilizer wastage here. In conventional farming, fertilizer may be lost through leaching and runoff, and even fixation of the soil. In what happened in the nutrient, in the soilless system, nutrient are applied in measurable quantity, and plants absorb the nutrient more efficiently. Fertilizer use efficiency increases here. This reduces the reoccurring of fertilizer crops, and even reducing weed cost management. See, in since there is no field soil where weed growth is greatly reduced, because in the field soil there are many contaminants. In weed seeds there will be a lot of weed seeds. In this one means soilless substrate, perlite are produced at high degree temperatures, and even cocoa peat are well screened, washed, and well sterilized, and so it is disease free even, and even weed free also, and lower yeah, that's why it's a lower incidence of soil-borne diseases. Though many fungal infections are very less in case of soilless media, and it produces better quality of product of, and even you can produce your you are cultivating inside the greenhouses, means you can produce the plants throughout the year. It will even labor cost also reduced. See, tillaging, weeding, soil preparation, earthing up, and weeding, and pest management. A lot of things are there that can be reduced through soilless media. And this media also, you can reuse the media. Like cocoa peat, you can use 2 to 3 crops cycle. Perlite, several crop cycle. When in similarly cocoa chips also, you can use multiple times. And higher net, yeah. Yeah, those are the many advantages we have.
Okay. Sir, what training or technical support is essential for beginning adapting soilless farming?
Soilless means training. Training means actually there is nothing like training. It is like research, means we have to do some things, and trial and error method only. Like this, there are many common things, like cooking, washing of cocoa peat. That is the common thing, and the nutrient requirement that are to be known for many farmers. Like soil, we can use nutrient here also, but in organic way, means we can use um, organic nutrient like neem cake powders, and pangamia cake powder, and different types of media. Like farmers should understand the water holding capacity, air porosity, and media selection for different crops, and media preparation and types of media, what are types of media will not, and there's no irrigation frequencies, irrigation durations, nutrient solution preparation, fertigation schedules, and and managing drainages and the and other things like pH and EC, using of EC and pH meter, calibration of the instruments, temperature, and correct nutrient solution based on the result whatever they are achieving. And the EC and pH should be crop specific and dissolved salts of the nutrient, and they plant nutrient requirement, macronutrient, micronutrient deficiency, and toxicity symptoms. Uh, Preparing of stock solution in case of hydroponic and all, they have to know preparation of stock solution, preventing fertilizer incompetencies. Means there are some incompetency in fertilizer also. Water quality assessment like TDS, hardness, and sodium level, electrical conductivity, and water treatment, and even disease and pest management, fungal disease, bacterial disease, viral disease, flies, white flies, aphids, and uh, hygienic sanitization, and integral pest management like green and the greenhouse and shade house management. These things are they generally know in normal soil, regular soil cultivation also. And they already know cross specific cultivations like tomato, how to prune and how to thin, and capsicum branch management like cucumber vine training, and they readily know their crops. uh, Equipment operation and maintenance like drip irrigation system, filters, and fertigations, pumps, EC, pH meter, etc., and record keeping. In the previous what they have studied, that has to be noted in that has to be noted and corrected in the next term of their crop. And then economical planning, like they know, uh, and the like soil testing, they can test the here this also cocoa pit testings like carbon nitrogen ratio, and uh, CEC value, and EC, pH, and particle sizes, etc. They can get the value from any outside laboratories. Likewise, farmer has to monitor these things.
Okay, thank you very much, sir. We have now completed the round of questions on behalf of agricultureinformation.com. We would like to thank Mr. Chethan Poojary for the talk and for answering the questions. This meeting will now be closed.
Thank you.
You're
Thank
most
you.
welcome, sir.